So the problem is nobody, okay. So, when you guys are designing a research study, you probably want to know how big your sample size should be. What kind of stuff do you know about sample size already? It can't be too big because why could you not make your sample too big? Hmm? But normal is good. Oh, no. So you guys should know that your sample size has to be less than 10% of the population. So it can't be too big. It can't be more than 10% of the population. That's a 10% condition. Okay. Also, you should know that your sample, if you're talking about means, needs to be greater than 30 for it to be normal. That's a central limit theorem. And then you know that your proportion times your sample size should be greater than or equal to 10. So you have conditions that you've been following. So when you're designing a study, it might be a really good idea to give yourself a small calculation to make a ballpark of what type of sample size you want to use. Now, if we look at the yellow sheet, did you guys write on here yesterday? Margin of error? Okay. You should. That's one of the things you're allowed to write on your yellow sheet. And it says a confidence interval, the margin of error is the critical value times the standard error. Okay, so for what we're doing, I put margin of error, critical value, standard error. Critical value is Z star. Standard error came from this right here. We did this yesterday. Okay, so we're going to plug in something in the margin of error, something in Z star, and something in P hat, and we're going to solve for N. We're going to actually do algebra. Isn't that crazy? It's going to be great. Okay, now, if you guys are designing a research study, do you really know what the proportion is going to be before you ask it? No. So if you don't know, you're going to use 50-50 as a conservative estimate. Does that make sense? Since if you don't know what it is, use 50. Okay. In a company's prior survey, 80% of customers said they were satisfied. Okay, this is giving us some prior information. So that means that we can use P hat equals 0.80. It says in a company's prior survey, 80% of customers said they were satisfied. So we're going to use that for our calculation. Find the sample size needed for a margin of error of at most 3 percentage points. Okay, so we're going to put margin of error 0.03. Make sure that when it says a single number here that you put a 0 in front. With 95% confidence, what is the Z star for 95% confident? $1.96. Do we need to go over how to find that? Okay, so plug in all of those things into this formula. So margin of error is 0.03 is greater than or equal to 1.96 times the square root 0.8, 1 minus 0.8 over N. Okay, now let's talk about order of operations. Okay, first thing you want to do is divide both sides by 1.96. Does that make sense? Okay, so I'm gonna go. Like that. Okay, so if I were you, by the way, I would actually get out my calculator and make myself hit these buttons because um you'll see why. Okay, what do you think the next step should be algebra wise? Square it. Okay, now when you square this, be really careful looking at the answer. It's really important that you guys are analyzing your calculator properly. Do you see what I'm talking about? This is scientific notation. Okay, so you have to like keep your eyes open for that. And it's just because 0.01 squared is a teeny tiny number. So I'm just gonna write this 2.3428 times 10 to the negative 4. Second semester here, we're going to have some scientific notation in our problems. It's not a big deal. Just keep your eye out in your calculator. Okay, now you have a couple options at this moment. You could put this side over 1 and cross multiply, or you could multiply both sides by n. What would be the best for you? Okay, now really quick, if you multiply both sides by n, and actually either way, this moment, the inequality sign flips. Okay, so back in, I don't know, Coach T does his own thing, but if you took Math 1, Math 2, Math 3, pre-calc, we taught you guys to do open or closed circle and test the point on either side to decide where it goes. We did not teach you to look at the less than and make the arrow go less than. We taught you to test a point. So remember, like, you took pre-calc with Guyan and you'd have like the points and we'd have to test the zones. Okay, we didn't teach you, you don't remember that?
I don't remember, I forgot.
Anyway,
Oh, thanks, Brian.
anyway, when you're doing inequality, because we don't teach you the tricks, is what I'm trying to say. When you have inequality problems, if you divide by a negative, you have to flip the inequality. And if you multiply by the variable on the bottom, to multiply by n on both sides, you have to flip the inequality. So, it'll make sense to you, but I just need you to know this, at this moment is when you would flip the inequality. So cancel that. Cripes. I wrote this wrong. I wrote it wrong. This is, you are supposed to flip the inequality and this is supposed to be less than or equal to. This is not going to cause you a math problem, though. It's not a big deal. Yeah. I had this all in my head as the flip, and then I flipped it again. Go back and change all of your guys to less than or equal to, except for this last one. Um, to be 100% honest with you, this isn't really going to affect your problem, but you'll see in a second. Okay, anyway, so 0.8 times 1 minus 0.8. So I have so now I'm going to divide both sides. So 0.16 divided by that. So that means your sample size at a minimum needs to be 683. And the reason that I said that the sign really doesn't matter is because you're going to round that up to the nearest whole person anyway. Because you're not going to have a 600, you're not going to have a 0.95 of a person. Okay, so let's just look at the order of operations one more time. Start by plugging the things in. Divide both sides by 1.96 or whatever Z star is. Square. Multiply both sides by n, and when you do so, flip the inequality. And then multiply these and then divide both sides to get n by itself. Are you sure you're all good? It's not bad. Okay. What? Oh, this is actually the end of the notes, but that doesn't mean that we're done. We're doing something in the packet too for a minute, but then we're done. What's wrong?
I'm shocked.
Oh, okay. If the company wants 99% confidence instead of 95% confidence, so be more confident. Would this require a larger or smaller sample size, assuming everything else remains the same? We're going to actually list our explanation two different ways. Either way, it's 100% full credit. Please listen. It just depends on if you want a common sense explanation or a math explanation. It depends on you, whichever one you like better. So common sense says, if you want to increase your confidence in something, should you ask more people or ask less people?
More.
Ask more people, right? That's the common sense explanation. So to increase confidence, Okay, that's this like stats common sense explanation. To increase confidence, you would ask more people, larger sample size. That would make you feel more confident about your answer. Okay, now we're going to talk about the math answer. So if you could scroll up for me on your paper to the top of the page where the formula is. Okay. Which one of these things, there's three things here. One, two, three. Which one of these three things has to do with the confidence level? Is it the margin of error? Is it Z star? Or is it the standard error? Which one of those three things has to do with the percent confidence? Z star, Z star. Okay, and the reason is you put the 95 or whatever into inverse norm to get it. Okay, Z star. Is it on the top or the bottom of this fraction? On the top. Okay, for everything else to remain the same, if I make this number bigger, then what would I have to do with this number to balance it out? Bigger, because it's on the bottom. This is on the top, this is on the bottom. I'd have to make them both bigger to balance it out. That's my math explanation. So we're going to explain it like this. Please stop. Okay, now if you guys could grab your packet, please. Please don't grab each other's packet or draw things on there, rip it up. That'd be cool. Usually don't have to say that to seniors, but you know. Okay, I put this together to help us start to memorize the FRQ process. This is not what we did today, by the way. This is what we did with the trash get ball business. But I have a bunch of it typed in to try to help you follow the process. Okay. Consider this following scenario. Follow the prompts to complete a four-step process for finding the confidence interval for a proportion. A husband and wife, Mike and Lori, share a digital music player that has a feature that randomly selects which songs to play. A total of 2,384 songs were loaded onto the player, some by Mike and the rest by Lori. Suppose that when the player was in random selection mode, 13 of the first 50 songs selected were loaded by Lori. Construct and interpret a 90% confidence interval for the proportions of the songs on the player that were loaded by Lori. Okay. All right, so I've given you a sentence starter. It says, we wish to identify the true proportion P equals. And then what you do is you just go up to the problem and start copying off of it. So we wish to identify the true proportion of P equals proportion of songs on the player that were loaded by Lori at 90% confidence. The inference method here is a one sample Z interval for P. Okay. Random. Do you see the word random in the problem anywhere? Yes. What you do is you copy the wording out of the problem. Random selection, check. Independent. Independent is our 10%. N equals, what is the sample size? 50. Is this a true statement? Is it less than 10% of all songs on the player?
Yeah.
Yeah. What?
Oh,
Most of the time you don't know, to be honest with you. This time you do. Okay, normal, this is our large counts. Okay, now what did I tell you guys? Do you have to do n times p in a problem like this? No, they already gave you n times p. It's 13. Do you guys all see where the 13 came from and the 37 came from? Okay. Done. Okay. Calculate. Statistic. The statistic is 13 out of 50. So these are the ones that were selected by Lori, which is 0.26. Is it 0.26? Okay. Standard deviation of statistics, square root 0.26, 1 minus 0.26 over 50. Okay, do you still have it in your calculator? Are you lucky? Does anyone have the 90% one memorized yet? Yeah, you can just write it down. On the AP exam also. I would probably ask you for like a 92.7% confidence interval though, just to be a jerk. I'm not really a jerk. I just okay. All right. Confidence interval statistic plus or minus critical value times standard deviation. Okay, so 0.26 plus or minus 1.645 times 0.062. Any questions about how I got this stuff? So I multiplied the two numbers here and I got that, and then I did this minus that to get the front number, and then this plus that to get the back number. Okay. We are 90% confident that the interval from 0.158 to 0.362 captures the true proportion P equals of songs on the player. Okay, flip when you're ready. Mike and Laurie are unsure about whether the player samples the songs with replacement or without replacement when the player is in random selection mode. Explain why this distinction is not important for the construction of the interval in part A. I know you don't remember. It's fine. I'm gonna find you the picture. 1 second. I'll help you. I got this. Give me a moment. It's gonna be great. Did you know it? Did somebody know it? Okay, this has to do with the 10% condition. So remember that was the hat that had every person in Benicia High School's name on it. And we said, well, the probability of selecting 1 out of 1410 is really not that different from selecting 1 out of 1409, 1 out of 1408, 1 out of 1407. And it's totally fine up until you get up to 10% of the population. Okay, 10% condition. If your sample size is less than 10% of the population, you can treat a distribution as binomial even without replacement. Okay, so okay, B, C. Write a sentence to interpret the 90% confidence level used in the interval in part A. This is that long, terrible sentence that I told you were going to have to memorize this chapter. Okay. Does anybody remember how it starts? Mhm. Mhm. That's your next hint. We construct What are we doing in these problems? Yeah, and what confidence in this one? Okay. Hmm. Okay, B. This is just a fun question I threw in. Use your answers from part A to determine the probability that if theoretically P is 0.26, then more than 18 of the first 50 songs would be selected by Lori. Okay, so what is 18 out of 50? 0.36. So we want to find the probability that X is greater than 0.36. What do I do? Channel your chapter 7. Normal CDF. Mm-hmm. Point 0.36. 2. Yep. Then look back at your mean and standard deviation from A. What was it? 1.062? Right. Does that look right? No. Mhm. 5% chance that more than 18 of the first 50 songs would be selected by Lori. Done. We made it through the week, people. But next week is gonna be longer. Next week, no, I don't mean in stack. I just mean that what's gonna happen is Wednesday's gonna feel like Thursday. And then Thursday's gonna feel like Friday. Because you think that you have a block day, your brain's gonna be like, no, Thursday's Friday, but you have to come back here on Friday. That's why it's for. It is. Yep. What's your fourth period?
Business, that's the.
Oh, that's the one, yeah. What are you doing that day?
Thank you.
I don't remember.
Yeah, I got a miss.